let's see. Let's talk real quick about, let me just tell you what a pulley, okay, one thought problem about a pulley, and then we'll do Newton's third law. Okay, but I got to say one thing about a pulley, just so you'll know, is that a pulley changes the direction of a rope. A rope, but maintains constant tension. So you will see problems like this. A rope goes over a pulley like that, and here's a mass M. Can you draw it like that? There we go. Now, the rope is turning. It's going around the pulley, and it's attached here solid, and the mass just hangs there. So we could say, what's the tension? Right? The tension, well, to get the tension, do a free body diagram on the mass. Right? And then the mass looks like this. Oh, I don't draw the body. You want to do a free body diagram, I'm sorry. A little dot. Right? mg down, and then tension force up. Because the tension applies a force equal to T wherever it's connected. Right? And it's going to hang straight down, so the tension is straight up. Right? So the tension here, sum of the forces in the y equals 0, because it's static, is tension minus mg equals 0, so tension equals mg. Done. All right, so you'll do lots of problems like that, and the main thing I want you to see when they get more complicated is that the tension remains constant. All the pulley does is change the direction of the tension. Okay? There are more complicated problems. I'll put a couple online. But here is a tricky thought problem before we do Newton's third law. What about this? Here's a table with two pulleys and two masses hanging, each one hanging under the influence of gravity. Right? Each one pulling at mg. And maybe you can tell I'm going to trick you. Each one is pulling at mg. What's the tension? Think about it for a second. What's the tension? And I'm going to do a 3 count, and you're going to say, everybody's going to say what they think the tension is. 1, 2, 3. 0. I heard 0t and 2t. Okay. The answer's t. It's only t. It's tempting to think that the answer's 2t because there's two masses pulling, isn't it? A rope pulls with its tension in two places. Okay? This rope pulled with mg here, and it also pulled with mg here. Okay? This rope is pulling with mg here, and it's pulling with mg here. Okay? So sometimes you don't see it in a problem, but the rope is always applying its tension at two ends, even if one of the ends just disappears and isn't part of the problem. Okay? You could also get it just by saying, I don't have to think about all this. I'm going to do a free body diagram just on this. It'd be the same process. The tension would have to be mg. If the tension were 2 mg, the two things would fly up in the air. It'd have to be a spring or something like that. Okay?